What lights up my love of physics? Rock? But why of all things would a rock light up my love of physics? I mean, I could have chosen so many cool things like black holes or all of the recent discoveries in particle physics. So what makes this rock so inspirational? The elements within it were not created on Earth. They were formed long before the birth of humanity in the fusion and death of massive stars. These elements include copper, iron, and silicon. For the early part of human history, they were out of reach, locked inside hard sedimentary rock. That was until around 5000 BC, when humans began to smelt rock in simple furnaces, allowing us to extract metal for the first time. Over the next millennia, humans began to shape these metals into components, and in 1831, scientist Michael Faraday found that by moving a magnet through a copper coil, he could generate an electric current. I demonstrated this principle through a simple experiment. I attached a copper coil to a clamp stand. I then used wire to create an electrical path from the coil to a digital ammeter, which I plugged into my computer. I then dropped a strong neodymium magnet through the coil. As the magnet passes through the coil, a brief current is induced due to the changing magnetic field, and mechanical motion is converted into electrical energy. Faraday's fundamental discovery that these changing magnetic fields were able to induce an electric current laid the basis for generators, electric motors, and for the power grids that supply our modern world. Once we were able to generate electricity reliably, our technological development was exponential. The earliest circuits were simple loops, such as this one, which has a battery, a lamp, and a switch. However, new components were quickly introduced, such as transistors, which allow currents to be amplified and switched electronically, replacing mechanical switches. At the same time, we refined Earth's raw materials. Silicon was purified for semiconductors, and copper was refined into thin conductive pathways which can carry electrical signals across microscopic circuits. By layering these conductive paths with semiconductor structures, we were able to integrate billions of transistors into a single microchip, creating the foundations of modern computing. Today, we have created smartphones which can perform powerful operations in the palms of our hands. We've trained advanced artificial intelligence and developed supercomputers which can perform trillions of calculations every second. But it's easy to forget where we started. This all began with Earth's raw materials beneath our feet. That is why this rock lights up my love of physics. Without it, we couldn't have made supercomputers, artificial intelligence, phones, the power grid, circuits, magnets, wires. And without this rock, I couldn't have made this video.